Hi everyone, welcome to another video. Now, we looked in the previous video at this idea of recognizing what a function is. And we did this through visual means via our graphs, and we looked at some important concepts and ways that we can distinguish a function from just any normal relation. This was the idea of the vertical line test and this idea of putting something in, so putting one x value in and getting one y value out. Now we're going to continue with this idea, but just apply what we've learnt to a couple of practice questions. So hopefully this will be a relatively quick video, just so we can practice what we've learnt here. Now, we're going to do a couple of examples. We want to identify which of these are functions. Now, one of these is a set of points. 1, 4, 2, 8, 4, 16, and 5, 20. Now, typically someone will see this, get kind of nervous, and just start drawing this. But we're going to return to the main idea of a function. Now, this is actually such an important key idea that I'm even going to write it twice. I'm going to do this again in this video as well. So, a function is a relation. So, a relation where one x value produces one y value. Now, with this in mind, we can identify something important. Now, all of these x values are different, right? We have a value of 1, 2, 4, and 5, and each of these produces one unique y value. So I have one input, so one x thing going into this, and one output. And I get this for all of these points. So 1x produces 1y here, 1x produces 1y, and so on and so forth. Now, since this is true for all of these points, we can say that this obeys the definition of a function. There's a relationship between these points, because remember, a relation is just any ordered pair, so like points on a grid. And a function only happens when we get this one-to-one idea. 1x for 1y, all the way through. So this thing is a function. So if we were to graph these points, you can pause the video and try this on your own. Do a vertical line test through, and you'll see that for each, well, as this vertical line crosses the thing we're graphing, it will only cross at one point, meaning it is in fact a function. Now, this second thing here, we want to see if this y equals x squared plus 3 is in fact a function. Now, we need to revisit something that we learnt in earlier on in this series. We need to say, well, what is this x squared business? What type of graph is this going to produce? Well, anything with y equaling x squared is going to be an example of a parabola. Now, this is my regular parabola. So x squared is my parabola. And my 3, let's revisit what this meant in terms of the transformations. This is a vertical shift. Now, this is revision. I'm assuming everyone watching this has seen our parabola transformations and what that's sort of going to look like. But this just means the parabola is being shifted up 3 units. So I get this guy up here. Let's actually draw a line through it to make this nice and clear. That is my parabola. And we can see now, because this is a visual thing, we can try to do our vertical line test. So maybe here or here. And you can even do a table of values and see that this is true. But no matter where I draw my vertical line on this parabola, 1x here, 1x value is going to produce 1 y value. 1x value produces 1 y value. So this thing has a 1-to-1 ratio. 1x input gives you only 1 y output. You can even see this with a table of values. Now you may be doing quite a few numbers just to confirm this, but once you draw it and once you see visually that, okay, cool, this is just a parabola that's going to extend out, I'm always going to get 1x producing 1y. So therefore, this is a function, because this passes the vertical line test. My vertical line is only crossing my graph once, no matter where I draw it. Now, the very last example from our video today, where we're looking at recognizing functions, is this particular thing here. Now, we haven't looked at graphing these before, but we're actually going to get to this all in due time. But you can see here that this is actually the graph of a circle. Now, don't get too caught up on how we drew this. We're going to address this later in the series anyway. But we want to see if this particular thing is a function. Is there this 1-to-1 kind of ratio going on? Now, because I already have this shown visually, let me just draw some vertical lines and see what happens. So, after I draw in these lines, let me just mark the points where my graph is being intersected by these lines. Now I can already see here that 1 and 2 points on this graph are being intersected by the vertical line. And even when I draw the vertical line here, I have 1 and 2 places where it's intersecting. So that's already going to give us a hint at what this may be, whether this is a function or not. But just to double check, let's just draw up from my x value, so this x value to here, and this is the exact same x value going down to the bottom here. And I can see that this 1x value produces 1 and 2 y values. So this is 1 and a second y value. So I produce, so 1 x value produces 2 y values. And that's the same over here. My 1x value here produces 1 and 2 y values. So I can already see that I have a 1-to-2 relationship. Now, what do functions have to have? They're relations. We're always going to have this idea of an ordered pair, so an x and a y. But for it to be a function, we need to have a 1-to-1 thing going on here. So 1x value has to produce just 1 y value. If it produces more than 1, or in other words, if it fails this vertical line test, it passes through the graph 2 times, this is not a function. So we're going to say this fails my vertical line test. Therefore, it's not a function. 1x value does not produce one y value, it produces more than one y value. Therefore, this particular thing here, this circle, which we will look at later on in this series, is not a function. All of these, as I said, are relations, but for it to be a function, we need this one-to-one idea, where one x value produces one y value. One input gives me just one output. But this is how we can apply what we've learned to some actual questions and some actual graphs. And this is how we can recognize a function and distinguish it from any other relation. But thank you so much for watching, and I'll see you next time.